Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. In this video we are going to discuss about the equations that related to ideal gas equation and Dalton's law of partial pressure. So one of the applications of Dalton's law is to calculate the pressure of a gas collected over water. If we read this question, tutorial 5.1, question number 9, it is actually a water displacement method. Okay, so read the question. The decomposition of potassium chlorate at 24.0 degrees Celsius produces potassium chloride and oxygen gas. So from here we can write the balance equation. So potassium chlorate decomposed to potassium chloride and oxygen gas. Okay, balance the equation. Okay, then the gas was then collected over water. Okay, and 128 milliliter of oxygen gas was obtained at the pressure of 762.00 mmHg. So the gas collected is oxygen gas. This is our product. Okay, calculate the mass of the oxygen gas collected if the vapor pressure of water, so this is PH2O, equals 22.38 mmHg at the same temperature, okay, 24.0 degrees Celsius. Okay, so when the questions mention about collected over water, so we know that this is a water displacement method. Okay, so this is the diagram to visualize about the water displacement method. So we have potassium chlorate here. Okay, it is heat and the potassium chlorate is decomposed to potassium chloride and oxygen gas. So the oxygen gas will produce here. Okay, and we have H2O, okay, in this beaker. So the pressure measured here is the P total, which is the sum of the partial pressure of oxygen gas and also the partial pressure of H2O. Okay, so the pressure given 762.00 mmHg is actually the P total. Okay, this is the total pressure for this experiment. Okay, 762 is not a pressure of oxygen gas. So in order to calculate the pressure of oxygen gas, okay, we need to consider the vapor pressure of water. Okay, this value. So by applying Dalton's law of partial pressure, so P total is equal to P oxygen gas plus PH2O. Okay, we want to calculate the partial pressure of oxygen gas. So P total minus PH2O. The total pressure given in the question is 762.00 mmHg, and the vapor pressure of water given is 22.38 mmHg. If the question does not give the vapor pressure of water, you can refer to the constant value. Normally, the vapor pressure of water is given in the list of selected constant values. So we get the pressure of oxygen gas 7 39.62 millimeter mercury. So to calculate the mass of oxygen gas collected, we are going to use the ideal gas equation, PV equal to nRT. Okay, and to calculate the mass, we need to substitute the formula of mole here, mass over molar mass. Okay, and rearrange the formula so that we can calculate the mass. Put mass as a subject, so P V mR over RT. Okay, so we are going to calculate the mass of oxygen gas, and we are going to substitute the pressure of oxygen gas, the volume of oxygen gas, the molar mass of oxygen gas. Okay, but before that, we need to choose the correct gas constant, which is R. So the pressure of oxygen gas is in millimeter mercury. Okay, we have this value. The volume is given in milliliter, so we need to convert the volume to liter. Okay, and then the molar mass of oxygen gas, okay, 32 gram per mole. Temperature is in Kelvin, so we can use the third gas constant value, okay, R3, which is 62.36 millimeter mercury liter per mole per Kelvin. So to use this value, okay, to use this gas constant value, you need to make sure that the pressure used is in mmHg or torr, and the volume is in liter. Okay, you can also use the first gas constant, which is 0.08206 atm liter per mole per Kelvin. Okay, but you need to convert the pressure, okay, this value, you need to convert the pressure to atm. Okay, and the volume still in liter. Okay, the easiest way is to use this gas constant, because we don't need to convert the pressure. Okay, just use in millimeter mercury. Okay, since we have all the values, so just substitute in the formula. The pressure of oxygen gas is 739.62 mmHg. Okay, the volume is 0.128 liter. Okay, the molar mass of oxygen gas is 16 times 2, so 32 gram per mole. Okay, since we use the pressure in mmHg, so the gas constant is 62.36 mmHg liter per mole per Kelvin. Okay, and the temperature in Kelvin is 297.15 Kelvin. Okay, let's cancel out the unit. mmHg, liter per mole, Kelvin per Kelvin. Okay, so we will get the mass in gram, and the mass is 0.163 gram. Okay, that's all. Thank you.